Today we will be working on exercise A from chapter 19 of the Giancoli textbook. So our first step is to read the problem. This problem is asking, you have a 10 ohm and 15 ohm resistor. What is the smallest and largest equivalent resistance that you can make with these two resistors? So this brings us to step 2, which is identifying the what. So what do we know? Well, we know that R1, or the resistance of 1, is 10 ohms, and R2, the second resistance, is equal to 15 ohms. Now we can go on to step 3, which is asking us to find the right equation to use. Because we've read the problem, we know that we're trying to find equivalent resistance. And we can actually end up using two equations for this problem. In a series circuit, we can find the Req by stating that Req is equal to R1 plus R2 plus R3, etc. However, in a parallel circuit, in order to find the Req, you have to do 1 divided by Req is equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3, etc. Now that we have these two equations, we can plug in the values from the what do we know section. So we can write Req in a series circuit is equal to 10 ohms plus 15 ohms, which is equal to 25 ohms. In a parallel circuit, we can write 1 over Req is equal to 1 divided by 10 ohms plus 1 divided by 15 ohms. However, we need to find a common denominator for this problem because you can't add 1 divided by 10 plus 1 divided by 15. So in order to do this, for the 1 divided by 10, we can multiply this by 3 to get 10 to 30, since the common denominator between 10 and 15 will be 30. So this ends up being 3 divided by 30 ohms plus 2 divided by 30 ohms, which is equal to 5 divided by 30 ohms. We can now simplify 5 divided by 30 ohms to give us 1 over 6 ohms. And now this tells us that our Req is equal to 6 ohms. So now we can see that the largest Req possible from these numbers is 25 ohms, and the smallest Req possible is 6 ohms. And that, my friends, is the final answer.